this is where we left off with why is it that especially these animals, the avians, the birds, why is it that they have to have this four-chambered heart? Yes, reptiles have it. Salamanders or amphibians have a three-chambered heart, which is a precursor to this. But why is it that these animals definitely have to have a four-chambered heart that's completely separated with a high blood pressure? Because what is it when it comes to migration? Even when the birders of New York or birds of New York, we're talking about some of these animals or birds that go through this process every year. And that's what? Starts with an M. Migration. That one of the, and I don't know if they're experts that they're talking or interviewing, but one of them had said, let's say 5,000 make the trip. Next year, it may only be 4,000 or 4,500. That not all of them are going to make that annual trip because it's so taxing on their bodies. Because what two things do all cells need for this high metabolism? One is what? I didn't. Nutrients and oxygen. The only way to get that continually circulated is with a very efficient respiratory system and circulatory system. Now, they also have to have a way to break that down, and we talked about that with the digestive system. Okay, so here we have these types of blood cells, okay, erythrocytes. Now, what function do you think the majority of blood cells are for birds and mammals and humans, especially these? These are the most common blood cells that you would find inside the blood of any of these animals. Think about what you think their functions are. Yes, they carry oxygen. So, with that, why would it say this? If it's carrying oxygen, why would it lack a nucleus? And one way to look at that is let's say this coffee cup had an indentation from the bottom where it shoots up and over and back down. Kind of creates a cube in here from the bottom. So that cube is going to do what inside this coffee cup? Take up what? Say that again. Takes up space. Okay? So what that means then is you can't hold as much fluid in here. You remove that cube, it can hold more fluid. If you remove that nucleus, it can carry more oxygen. So one question I think maybe many students have, and I think this is true, well, if it doesn't have a nucleus, how does the function of this cell know what to do? Well, it's still going to be a different form of DNA. You have what's found in the nucleus, but there's another type of DNA that's also found, and it's a specific organelle DNA. It starts with an M as well. It's what? Mitochondrial DNA. That's right. And I believe just with that, that would take the place of this nucleus. So therefore, it can carry more oxygen. Okay. So, what is it about these? It says phagocytes. Okay. Blood cells that repair wounds and destroy microbes. So, how is it that these cells destroy bacteria? It says it does, but how do you think it does? What's the process of phagocytosis? In other words, you linemen, it's what you don't want to do when you're on the offensive side. Because then the yellow flag gets thrown. Yeah, in other words, if you wrap your arms around or something to that effect, you're or if you're tackling a person, that's what you want to do, wrap your arms around and bring them down. So phagocytosis then is wrapping itself around these microbes and then digesting. Okay, so one of the things we said, you have to have lots of nutrients and lots of oxygen. And animals has certainly gone through the adaptations to do so. I almost said, who can I pick on here? I think I got the right idea who I'm going to pick on. Who do you think I'm going to pick on? Who do you think I'm going to pick on? No. Who do you think I'm going to pick on? You said Sheldon. I'm saying no. Who am I going to pick on? No. Is that all right? Can we pick on you, Tori? Okay. So when we look at this, okay, structure which air flows continually, all right? We're going to say that you've got this 68, 69, 70 Dodge Charger, okay? But you really want to crank up the horsepower in this Charger. You just nod your head yes. Just say, okay, I'm gonna get more horsepower out of this Charger. But it requires a cutting torch. You're gonna kind of destroy the hood a little bit. So you're gonna take this cutting torch, you get this nice pretty paint job on the hood. You're gonna cut a hole, box in there. Okay? Because you want to attach something to the carburetor so it sucks more of this into the intake. Now, maybe my way of explaining this is incorrect. We're changing this student's Charger to a blank Charger. And maybe I'm wrong with this. Because what would the difference be between a Charger and a supercharger? Does that not have that large intake that you have to cut through the hood to mount on top? Right. Think about, now you're not writing this down. How do you know, you're going to know how to do this if you don't write this down? Oh. Well, it doesn't mean you can't fix it up and sell it. Okay, fair enough. So what is it about that? That's an example. Why is it that that car has so much more horsepower? Right. Probably a lot more. That is way above and beyond what my knowledge would be. But as that car is going down the road, okay, that is taking air in and sending that where? Down into the engine, because, okay, when you're having more oxygen in there with your fuel, if there's more oxygen to burn with that fuel, you're going to get a lot more horsepower. So what we see happening here, it's not that we're saying these are superchargers, but what happens is through their respiratory process, and we'll talk about this in a moment, that even as a bird is exhaling, they still have oxygen going through their lungs and into their bloodstream. Even, okay, so they breathe in, okay, that's the first part of the cycle. It doesn't go straight to the lungs. It goes to these structures right here, and there's two sets of them. You have a posterior and an anterior set of air sacs. So as that first breath is coming in, it goes into the air sacs rather than the lungs, okay? Then as they exhale, okay, that oxygen is then moving from the posterior air sacs into the lungs. Then you have another inhalation, and it's going to the posterior air sacs in the lungs, the anterior air sacs then back out. But what's happening is it's just going to be a continual supply of air. And I think that says it right here. Birds receive continual oxygen during both inspiration and expiration. Okay, so there's two cycles. There's one where air has to go into the air sacs, and then from the air sacs then into the lungs. And that's what we mean by the two cycles. Okay, air sacs and lungs. And it never really occurred to me until I just read this on here. And I don't think you can really make this analogy, but when you see this term right here, since we're talking about engines, what comes to mind when you see that term compressor or compression or? Well, yeah, that's in a diesel vehicle, that's true. But here we're talking that of a what type of? I heard something. Oh, right. That's true. I guess I was thinking it's your turbine engine. I never. Of course, we're not talking about these with birds because if you know anything about this, you have intake, compression. Now this is the air as it goes into the intakes in these engines. Then there's a compressor. A compressor. Why is that an advantage for these turbine engines? So if you compress this air, it means you're getting more or less. Yeah, you're getting more. You're compressing more air into a smaller space, and then you go through the what do I want to say, the combustion stage, and then finally the exhaust. That's the idea of a four stage turbine engine. But the idea behind this is, remember, we said the demands on these animals is so great. They have to have oxygen and they have to have nutrients, and this is the structure that allows that to happen, their respiratory system. Okay, after this we'll continue at that point tomorrow. So again, this is just explaining that process. When it says two stages, one is for the air entering the air sacs, and the other is talking about the lungs then. Now, for you gentlemen out on the field last fall, I'm sure there got to be a point where you don't want to come out of the game, and I get that. But at some point, maybe you need to have that substitution so you can catch your breath. Did that ever cross your minds at all? Or were you in just good enough a shape, and maybe you were, that you're in good enough a shape that you did not ever have to do that? Because I'm willing to bet when you two, especially yourself, probably yourself, and probably yourself, the moment you stepped on the field, you really did not step off until there's a timeout, quarter, or half, correct? So then, when you go back out on offense, you're like, yeah, this is. Could you tell your opponent then? Oh man, they're kind of winded. Every once in a while. Just think, if you had this type of respiratory system, you would probably never tire. Well, yeah, you might. Your muscles would get tired, but you're continuous applying those high demands, and of course, that's going to be an advantage for these animals, even though they're quite small. That is quite taxing on them to have to fly 2, 3, 4,000 miles in the fall and the spring. Okay, so we will pick up with the excretory system tomorrow. And some of you were working on those papers. That's great. There's just one more evaluation on Thursday. How many of you believe the weather, man? And how many of you are thinking, oh gosh, not this again? But, so that's what's planned. So tomorrow, again, we'll discuss the excretory system and then have your second vocab quiz on Thursday. We'll catch up with you next time.